All right, welcome to day 5 of our SAT unit. We're going to get through page 29 in this video, so your homework will be to do the 4 problems on page 30 and 31. Now note, many of the ones we do today are no calculator. So if the question says no calculator right above it, be sure to be trying it with no calculator when you're doing your homework. So the homework ones we wanted to recognize that this is a 45, 45, 90 triangle, so those legs should be equal. So if we want to find AB, we could just find BC and it's the same thing. Well, from the 70, this is opposite and this is adjacent. So we could do tangent of 70 equals our opposite of 27 over our adjacent x. Cross multiply, you get x tan 70 equals 27. Divide the tan 70 over, and that gives you roughly 9.827. Remember, we should be in degree mode for that because 70 was a degree. In this one, notice those legs in the right triangle are the same, so we would want to recognize this is a 45, 45, 90 triangle, so angle EFG is just 45 degrees. Here we have a 45 from the full of 90, so this one's 45. Well, because these ones, we have 90 here, then these would each have to be 45. So if this is 8, this would have to be 8 as well, and that would have to be 8 as well, so the whole thing WY is just 16. And in the last one, we need to recognize across from the one angle, this is like D and this is like 2D. And you can use the reference sheet that you have on the SATs to help you there. But when you have a leg that is half of the hypotenuse, this would end up being like the D square root of 3. This is a 30, 60, 90. So angle QRS ends up being the 60-degree angle. So today we're going to work with things with circles. So this is on page 26. Again, many of these questions will be no calculator. So if we see it says no calculator there, we'll want to make sure we're solving it without our calculator. So we'll give you a moment to first read through the question. So this is from not too long ago. This was in unit 13. So when we're working with arc length, we could do theta over 360 equals our arc length over our circumference formula, which you can get right from the SAT reference sheet you have in your packet, which is 2 pi r. Theta is our central angle, which is 150. So 150 over 360 equals our arc length, which they told us was 15 pi over 2 pi r. Now note, this is a no calculator. So this is a prime example why in the unit, when we were doing this, I had you try and reduce things first. Well, notice on the right, the pi's wipe out. On the left, they both end in 0, so we can divide them both by 10. So now we have 1536 equals 15 over 2r. Well, notice the 15s are the same. So the denominator should be the same also. So that means we know that 36 should equal 2r. If we just divide both sides by 2, that means r is equal to 18. Now reread the question to make sure we're answering what they wanted. They did want us to find the length of the radius, so we just have choice D. So when it's no calculator, if you have a proportion, try and reduce it, because it would be hard to, without a calculator, cross multiply and do like the 15 pi times 360. Moving on to the bottom of page 26, we'll give you a moment to read this question. So this is the same type of question. We'll have theta over 360 is equal to our arc length over 2 pi r. They tell us the central angle is 45, so we've got 45 over 360. The arc length they're telling us is x. And they tell us the circumference is 12 pi. Well, that's the entire 2 pi r. So here they were testing that you knew that that 2 pi r was actually just the circumference formula. So it might be tough to reduce 45 over 360. Okay, if you can reduce it, go for it. But I'll show you another trick here. Let's say we go to cross multiply. We're going to cross multiply, but not actually multiply it out. So then we'll divide the 360 over. So we'll have 45 times 12 pi over 360. And that's equal to x. Well, let's do some test-taking strategy. Notice we're going to have a pi in our answer. Well, that allows us to rule out these two choices. So right away, we're down to a 50-50 shot. And here's how we can go about reducing it. Look for things that are nice. 12 goes into 36. So we can divide this 12 out. 12 goes into 36 3 times, so this would become 30. So now we've got something a little bit more manageable. We've got 45 pi over 30 equals x. And now you might recognize that 15 goes into each of those. So this becomes 3 pi over 2. So that's just another strategy. Don't multiply it out initially if it's a no calculator, and then reduce it later on. But just the fact that we had pi in the answer allowed us to narrow it down to just two choices, even if you couldn't do any more than that. Going over to page 27 at the top, we'll give you a moment to read through the question. So we had problems like this in Unit 14. If AB is 10, we know that each of these is 5. They told us CD equals 10 as well. Well, you want to notice that CD is a radius, so we can strategically draw in our radius there. We can call this x, and then x is what we want to solve for. We want to eventually solve for CE. So this is a no calculator question. There's two ways you can do this. One way is you can do Pythagorean theorem. You got x squared plus 5 squared equals 10 squared. So that would be x squared plus 25 equals 100. Subtract the 25 over, and we get x squared equals 75. Take your square root, and x equals square root of 75. Well, you don't have your calculator, so you can't do menu number factor. Well, square root of 75 is not 5, because that would be square root of 25, so you can rule out that choice. They didn't say anything about rounding here, so this square root should come out nasty, so that rules out choice C. So it's either 3 square root of 3 or 5 square root of 3. So here's how you can do your prime factorization without having the calculator do menu number factor. All you do is you think of any two numbers that multiply to 75 other than 1 and 75. So a common one might be 3 and 25. 3 is a prime number. Its only factors are 1 and itself. So we're all done with that branch. 25 is not prime though, so we would keep going. So this gives us 5 times 5. Those are both prime. So now that tells us our prime factorization is just 3 times 5 times 5. So with that little prime factorization tree, we were able to do the same thing that menu number factor does. Circle your pair of 5s, one of them goes out front, and you get 5 square root of 3. So that would give us choice D. That's actually the harder way of doing it. The other way you could do it is you could look on your SAT reference sheet that we have at the very front of the packet, and notice that our leg of the right triangle is half the hypotenuse. So during the school year, we thought of this as 2D and D. So that would make this D square root of 3. So that would tell us that this is just 5 square root of 3 then. So that's the quicker way, or you could do it with Pythagorean theorem as well. Take a moment to read through the one on the bottom of page 27. So the minor arc is what fraction of the whole circumference? Well, all we have to do is take the 90 degrees that we have for the whole thing, or for our angle, divided by the 360, which is the whole. And we need to see which does this reduce to? Well, you can divide them both by 10. That gives you 936. Divide those both by 9, and we get 1/4. So choice C. Moving over to 28. So in our circle, we have a center of 3, 1. So your circle, it's always the opposite signs in the center. So we should see it x minus 3 squared and a y minus 1 squared. So that rules out those two choices. Well, this is saying we should equal either 49 or 50. Well, this was our radius squared. So we'll show you two ways that you could do this. Way number one is turn this into a right triangle. If this is at 3, we're going 1, 2, 3, 4, 5 boxes over, 1, 2, 3, 4, 5 boxes up. If you do Pythagorean theorem, that's 5 squared plus 5 squared equals x squared. 25 plus 25 equals x squared. So x squared equals 50. Well, this hypotenuse is the same as the radius, and we would need it to be the radius squared. So that just gives us the choice D there. So that's one way you could do it. The other way you could do it is you could take your x minus 3 squared plus y minus 1 squared equals r squared, and sub in the point that's actually on the circle. So we would do 8 minus 3 squared plus 6 minus 1 squared equals r squared. And we would neaten up the left to see what r squared should equal. Well, 8 minus 3 is 5, 5 squared is 25. 6 minus 1 is 5, 5 squared is 25. So when we add those together, we get 50 equals r squared. So that leads us to choice D as well. So two different ways that we could go about doing that. I'll give you a moment to read through the bottom of page 28. And now based on reading it, we'll give you maybe 30 seconds or so, see if you can figure out which choice it should be. So notice they all have the same thing inside the parentheses. So we know they're opposite signs, but they all have pluses. So this is really just testing that you know on the right side it's radius squared. Well, if we have square root of 10, square root of 10 squared is just 10. So choice C. We'll give you a moment to read the top of page 29. So round your answer to the nearest tenth. This is a calculator one. So starting out with our center, remember we have the opposite signs when we put it in the equation. So we're going to have x plus 6 all squared, plus, in our parentheses, we'll have y minus 1 all squared, and that's equal to r squared. So we're going to sub the 7 in for x and the 12 in for y, and then solve for r. So we'll have 7 plus 6 all squared plus 12 minus 1 all squared equals r squared. And I want you to punch in the left side in your calculator, work to get r alone, and then round to the nearest tenth. So we'll give you a minute to do that. A box is going to pop up to have you put your answer in when you get that. We should have got 290 when we put that in. On the left, when you took the square root of it, we got 17.029 and change for r. So the nearest tenth, r should be 17.0. And we'll go to the bottom of page 29 for one last one that we'll do as a group. And then the last 4 are ones you will do on your own. Again, remember on the homework, if it says no calculator, try it without a calculator. If it doesn't say no calculator there, that means calculator's allowed. Like on this question here, calculator is allowed because it did not say no calculator. So we want to know what the radius of this circle is. So to start out, we need to get a 1 in front of our squared terms. So we're going to divide everything by 36. So this will give us x squared plus y squared minus 1/3 x minus 3/4 y minus 2/9 equals 0. Okay, and you can just divide those all right on the calculator. So we want to add the 2/9 over to the other side. So we'll have equals 2/9 over here. And on the left side, we want to group the x's and the y's together. So we're going to have x squared minus 1/3 x plus, and then we got to leave a blank, plus y squared minus 3/4 y plus, and leave a blank. And what we have to do with this is complete the square. To complete the square, we always did b over 2, put it in parentheses, and squared it. So we're going to have to do negative 1/3 over 2, and then square it. And we'll give you a second to put that in your calculator. Make sure the negative 1/3 is in the numerator, and then divide by 2. So when we divide by 2, we should get negative 1/6. When we square it, we get 1/36. So we'll put 1/36 here, but whatever you add to one side, you've got to add to the other side. And we'll do the same thing for the y. We'll do the negative 3/4 over 2, all squared. And the reason that's the b value is a is we consider in front of the squared term, b is in front of the raised to the first term, and then c would be our constant. So when we divide that by 2, we should get negative 3/8, and when we square it, we'll get 9/64. Well, notice in this question, they don't care about the center at all. They just care about the radius. So we just want to look at this part here. We know that should give us r squared. So take a second and punch those in and add them up in your calculator. So we should get 25/64. And that's what r squared is. So to figure out r, we'll just take the square root. Well, when you take the square root of a fraction, you just take the square root of top and bottom individually. Square root of 25 is just 5. Square root of 64 is just 8. So we get 5/8 for our radius. So that's it for this video. You got page 30 and 31 to do those 4 problems for your homework. Make sure to take pictures and upload them on Schoology. And then he wants to say no calculator. Be sure to try them without a calculator. Have a great rest of your day.